afternoon everyone, we'll be sharing about our Chem AA task. So truth be told, Coke or Fanta, which is more acidic? So to summarize our project, our hypothesis was that Coke would be more acidic. In order to conduct this experiment, we compared the acidity of Fanta and Coke via the maximum temperature change recorded by the thermistor. Before explaining our methodology, here is some context. Soft drinks such as Coke and Fanta contain acids such as phosphoric acid and citric acid that harm the teeth enamel, also known as hydroxyapatite or HA crystals. Looking closer into the chemical reactions that happen in our teeth, acid produces hydronium ions that react with the HA crystals during demineralization to form ions that dissolve, leaving the teeth more vulnerable to damage. In contrast, when less acid is present, the alkaline saliva promotes an environment for remineralization by providing fluoride ions as a catalyst to form fluoroapatite that coats the enamel, protecting it from further damage.
Coming back to our experiment, the reaction between sodium bicarbonate and acid is an acid-base reaction, as exemplified from how bicarbonate ions gain H+ ions and thus act as a Bronsted-Lowry base, while acid donates H+ ions and thus acts as a Bronsted-Lowry acid. These are the practical steps. Firstly, connect the microbit and thermistor to the computer. Measure each drain using a measuring cup and pour into the styrofoam cup. Record the initial temperature and temperature every 0.5 minutes. Add sodium bicarbonate ester. Repeat until a constant increase in temperature is observed for 2 minutes. And repeat this 2 more times and plot the average temperature recorded. Using Excel, we plotted out a curve of temperature against time. We recorded data points beyond the minimum temperature to plot an increasing and decreasing gas heat line to get a more accurate lowest temperature. When the baking soda was added to the drinks, a temperature drop was observed, indicating that the reaction is endothermic.
As for statistical results, these two graphs represent the data we collected. The maximum temperature change is calculated by deducting the minimum temperature from initial temperature for each drink. We found that the maximum temperature in Fanta was higher than Coke by only 0.1 degrees. So assuming that the density of the reaction mixture is 1 gram per cm cube and using the specific heat capacity value of 4.18, we calculated the heat change using Q equals mc delta T and found that the heat change for Fanta was greater than Coke, so it is more acidic. So moving on to assumptions, limitations, and safety precautions, we assume no heat was lost to the surroundings during the experiment, but in order to further prevent heat loss, we double cupped the apparatus with a styrofoam cup. One possible source of error would be the carbon dioxide that increases the acidity in the drink. This is due to the buildup of CO2 in the drink, which increases the formation of carbonic acid. So, to mitigate this issue, we left the beverage out overnight to allow dissolved carbon dioxide to escape. Secondly, the precision of the volume of reagents used is affected due to the limited apparatus we have. So to ensure greater reliability in results, we repeated each experiment 3 times.
One safety concern would be getting electric shocks from exposed wires of microwave. Hence, we ensured that there were no exposed wires and liquids placed nearby. To summarize our investigation findings, Fanta has a higher temperature change than Coca-Cola, which indicates that it has a greater heat change since the values of mass and specific heat capacity of the drinks are the same. Since Fanta has a greater heat change, this indicates that there are more H+ ions formed during the experiment and is thus more acidic than Coca-Cola. However, as the difference in heat change is a small value of 18.81 joules, we deem the difference negligible. While only 2 beverages were compared due to limitations as stated, future investigations could include a greater variety of drinks. With this research conducted, a similar approach to the mandatory nutrient-grade labels of beverages could be applied based on different beverages' varying acidities to better help consumers in choosing between beverages. Thank you.
So now we'll be sharing our feedback. So we think that it's excellently planned with a sophisticated and original experiment, and also it was organized in an effective and detailed manner. There's also a lot of in-depth analysis and logical conclusions made.
As for our constructing and justifying chemical explanations, we felt that it was quite clear and quite logically and well-reasoned and chemically sound. However, we felt that there was one part that we were unsure about. So you guys use maximum temperature as a way to measure acidity. However, it is only temperature change that measures acidity. So that's the only point. Because initial temperature may not be the same for both beverages. cleaning agents. Yeah, and other than that, everything else was quite effectively used to accurately explain the reactions, and maybe more about like the acid-base reaction, like the Bronsted-Lowry, whatever, the theories, things like that. And but other than that, it was quite well informed and comprehensive. Yeah.
Okay, I think for content and clarity of poster, I think that overall the poster was quite clear and accurate, and they also explain their chemical concepts. But I think that their layout can be slightly more organized. But overall, it's quite comprehensive and it's quite clear lah. Then, in terms of content, right, I think they could link a bit more to the real world context. Like, they mention about babies having irritable skin, so maybe like they can try to explain more on like how that works. Yeah.
And lastly, for like the presentation in general, we felt that it was a very engaging and highly articulated presentation and had like good clarity, and it was the use of scientific terms were very accurate with elaboration when it sounded a bit unfamiliar. Yeah. That's it.
I think the first comment that we have for your group is that like I think your experiment was quite well planned out, and I think you put a lot of thought into it, and also because the data was all organized in quite a detailed manner, like you have a lot of graphs and drawings and also like a table to show your data clearly, so I think that was good.
Another comment is that your analysis was also really well substantiated and supported by chemical evidence, as you guys used the chemical formula to show that actually the Coca-Cola gave the most heat.
We also think that your poster is very aesthetic and eye-catching. All the information is organized very well, which makes all the information very easy to understand.
However, I think that one improvement that can be made is like the order of like all the different components, because you do not know which one to read first, and also it's better if you want to put the safety concerns and precautions at the front so that it can better like basically it follows the procedure of the experiment, and then the reader has a better understanding of how the whole procedure works chronologically. And also a good thing to note is that references are included to show that it is credible. Yeah, so that's our feedback in general. Well done.